Ja, ich dachte, das ist jetzt
Welcome. What's up? Everybody has a drink. You can still get one if you want. Today is a chill format. You're free to get drinks, seats, go to the terrace if you feel like having some fresh air. This is a first kind of informal lightning talk style event that we will have. If the stream is fine, we can start with talks now. So Eugene, give me a sign if everything is working. You check it. I will just do the introductions for now. Yeah, we experiment. It's a new format. We will have 3 lightning talks, maximum 10 minutes each. We will not do a big Q&A round. We will make some short ones, but instead we want to focus on the networking and how it will go after talks. And that means that we will go on the fancy terraces. This will be a VIP terrace, and this will be a punishment terrace for those who don't behave well. No, just kidding. So we will like put maybe Q&A for talk 1 over there, Q&A for talk 2 over here, and we mingle, we speak with each other, then we will just come up with some topics to discuss on both terraces and in here. We're super flexible. It's an experiment. Let's see how it works. So 10 minutes maximum for each talk. Let's see how much content can our genius speakers fit into this time slot. So before we start, is the stream working? All good? Very good. Okay, so first, won't be possible without Ares Consulting, who is hosting us today. So we want to get to know the company, and I will welcome Tom first to give us some insights.
Yes, thank you very much. I will keep it very, very short because it would be a shame to miss the sunset on this beautiful terrace. Real quick, a couple words about ours. We are an IT consulting company focusing on cloud-native development. Luckily, for example, AWS now provides runtime for Python, so it makes a lot of sense that we do that here.
Just volume up.
We are around 40 consultants all over Germany. We are a remote first company. This is our only office all over Germany, and we use it mostly for networking events, for company gatherings, and I'm very happy to share it with you tonight. If you have questions about ours, if you're
feel free to do call for collaboration on your bot.
Like this is solve all your
everything allowed
in the area of cloud native, IT architecture, and other areas. Talk to me or one of the persons wearing an Ares t-shirt. And looking forward to tonight, to good talks, to good drinks, and to a lovely sunset. And wish you a lot of fun. Thank you.
Amazing introduction. Okay, now let's get started. By the way, food is on the way, so don't think like this is we skip it. No, it's gonna happen. But first, our amazing talks. So please welcome Johannes with his first talk about crypto trading. All good.
Perfect.
All good. All visible.
All right. Perfect. Does this work? Or
you need both. Yeah.
All right. So thank you all for having me. Thanks, Ares, and obviously also thanks, Anton, for giving me this opportunity to speak about algorithmic crypto trading. So since a little bit more than 1 year, I've been trying to set up a crypto trading bot together with a couple of friends of mine. And today, I'm just going to walk you through quickly through the experience and share some findings with you guys. And also, I'm a hobby photographer, so you will see some of my photos throughout the presentation. So let's jump into it. So what is algorithmic trading? So everyone that has already traded in their lives knows that trading is quite an emotional and stressful exercise, because every time you want to make money, you need to risk your money. And people that are trading also know that usually you do a lot of analysis on, for example, technical indicators when you come to decisions on when to enter the market or exit the market. So the idea came up to say, hey, the trading process in itself can be automated, and also the analysis of the indicators. So why not coming up with a crypto trading bot for that? So we want to minimize human interaction throughout the whole trading process. And also, ideally, you want to have an end-to-end automation so that the bot computes buy or sell signals and then actually also executes the trades on a marketplace. And when a trade is successful or not successful, then the bot should start all over again and do the same thing. So basically, you don't only want to compute signals that a human is executing, but you want to have some sort of an end-to-end automation. And when it comes to crypto trading or algorithmic trading in general, usually strategies are the most sensitive stuff. So a strategy in our context is an algorithm or an AI that computes the buy or sell signals. And this is also kind of like where, as I said, the sensitive information lays, because this is kind of like secretive, and the heavy legwork, basically executing the trades over the marketplace, is doable in our experience. So why crypto? Well, first and foremost, because crypto is a growing industry. So it's being heavily adopted, I would say, at the moment, which is, for example, shown through the different Bitcoin and Ethereum ETFs that have been granted this year. So if you come up with a technology, it's ideal to place it into a growing industry or on a growing technology. But also crypto, compared to, say, the S&P 500 or NASDAQ, is a more traded industry. So in the S&P 500, there are massive cash flows every month for example, pension funds. And that's why an S&P 500 is more in one directional market. It goes to the upside, usually. And cryptocurrencies, they're quite volatile. They go up and down. And that's because they're traded much. And that's what you can capitalize on. And also the fact that the big players start to adopt cryptocurrencies is an indication that the adoption hasn't fully happened yet. So if you come up with a crypto trading bot that trades smaller coins such as Matic, Solana, Polkadot, or Avalanche, you can assume that you're probably not trading against the best of the best from, say, BlackRock, which you would be doing if you come up with an algorithmic trading bot that trades the SP 500. And I mentioned it before, crypto is very volatile, which can make it a very stressful market for investors. And I've been there. I wrote it up and down. And that's not always easy, but as a trader or as someone who has an algorithmic trading bot, that volatility is what you can capitalize on and what you can make money with. So, some findings throughout the journey. And the first finding, and that's an assumption of mine, is that AI is most likely in its infancy for predictions in crypto markets. So crypto markets are very noisy, they go up and down a lot, and that makes it for AI, at least in my opinion, quite hard to predict. And I have an example, just a very quick one, that can underline my thesis. So what we did throughout the journey of several prototypes that we have computed and put live and then reevaluated, etc., is that we gave a machine learning model system a bunch of technical indicators. And it should predict logarithmic price returns. So basically, can the machine learning model predict an upward or a downward movement? And that machine learning model, we used a linear regression and a gradient boosting model for the ones that are more into that field, came to the conclusion that you can say with any statistical certainty that a price movement is happening. And that statistical certainty also for the tech savvy ones among us has been verified over R-squares or t-tests, which are statistical measurements. So based on an AI, you would say, okay, well, it's completely random. But if you put exactly the same indicators into a so-called hard-coded strategy, where you have an analyst, me, telling, hey, if that parameter stands like that, check this one, and if this one stands like this, do this, and you have a very simple checklist, you can compute a trading bot that is very profitable, which I find extremely interesting, because an AI system wouldn't have detected like that, but a human still can. Which leads me to another point, and that is a diversity of profiles, which is required to pull such a project off, because you can have scientists taking a look at the statistical measurements, for example, that I just mentioned, and come to the conclusion, oh, well, we can predict any prices with statistical certainty, which might be right, but if you have a trader looking at it, then the trader would be questioning what is statistical certainty, because a trader knows that if you're right between 25 and 35% of the time with your trades, and if you make a lot more money than you risk, then you can still be very profitable over time. And that 25 to 35% of the time might not count as statistical relevance for a scientist. So traders versus scientists versus software engineers think very different. And that's why it's key to juggle these different opinions and have good discussions and convince people of different opinions. And lastly, the volatility is key, because I just mentioned it. Say you only win 25% of your trades. That's statistically talking not a very good win rate, right? But say you win 10 at every trade and you risk 1 with every losing trade, then you would still over time be insanely profitable. And that is why the volatility in crypto helps you to have these large swings to the upside that you can, or to the downside, matter of factly, that you can capitalize on largely when you hit winning trades for once in a while. And yeah, that is some experience sharing about algorithmic crypto trading. And I don't know whether we're opening up for Q&A directly, Anton.
Yes, but only 2 questions, max. That is some responsibility. So who wants to have a question? All right. Nah.
Thank you very much. I have an question. If it's so trivial to build a bot driven by the some kind of human created heuristics to trade profitably and reliably profitably, as you mentioned, why you're not doing it? What's the catch if it's so trivial?
It's far from trivial, and that's why I've been working on this since more than 1 year.
For me, it's not obvious at all that it's possible. Basically, that you long term would have a positive mathematical expectation for whatever strategy you create.
Yeah, thank you for your question. And maybe I was being very confident throughout the talk, but maybe to put it in context, it's definitely not trivial. And that's also the reason why I'm standing here today to brainstorm new ideas and also get your feedback on it. But I think why I believe that it is long-term doable to have such a trading mod being profitable is because markets are always driven through fear and greed. So people are getting greedy and people are getting fearful. And when people are getting greedy, price moves to the upside. And when people are getting fearful, then price moves to the downside. And there are certain patterns within technical indicators that are always repeating these swings. And if you find these and if you can implement them, then that's at least my theory that you can have a long-term profitable strategy.
Very good. I saw the second question here.
Thank you, Johannes, for your talk. My question is simple, like what points you think is most profitable for your boards and what markets you're focused on?
Coins.
So I think if you're going into Bitcoin and Ethereum, you will have a lot of competition because these are the big coins. And I think also now that there are ETFs for both coins, you will be having fierce competition with different large financial institutions. So what we're doing currently is we're trading usually top 15 coins, sometimes top 40 coins, which are having market caps around definitely $1+ billion in market cap, and hence also quite some liquidity provided on the marketplaces. And that is an advantage that if there's high liquidity, then you can move in with some size without buying up the order books and moving the markets too much. So I would say focus on top 50 coins, but not Bitcoin and Ethereum.
Okay, well, if you had more questions, too bad, because now it's over. Maybe on the terrace after the next talk. So let us welcome Animesh here. And big thanks to Johannes. Come on. Big deal here.
Thank you.
Animesh, so you need this.
I need this. All right. Perfect.
So Animesh will tell us about hidden costs of Python, of using Python, basically, which is intriguing. I'm wondering how much. While we're connecting,
Yeah.
how they reach us.
Let's take a nice selfie. Yeah, like this.
All right. Good. So here we go. Warm welcome to Animesh.
Thank you everyone. So before I start the topic, I have to tell you, this is something I wanted to talk about a long time. And when the Munich Meetup was happening, I thought, okay, let's use Python as an example. All right? Okay, so let's start. In this talk, I'm just going to give you three things. Some overview of current usage. We can discuss some possible ways of optimization. I'm sure that people here who use Python definitely more than me can also teach me on this, on how we can do that. And lastly, I will leave you all with this question on should the current energy uses of programming language be discussed further or not? Okay. We all know Python is fueling billion-dollar industries. If you look at some numbers, AI is going to grow at around 280 billion. Data scientists, I think we have a lot of them here, right? Today, some data scientists, yeah. Now it's around 41 billion, and it's going to be around 279 by 2030. At least that's what Fortune Business says, yeah. And if we are going to analyze it and see how small operations can affect these costs, we can try to understand on how we can optimize it. I'll start with a very small example that I have here, okay? Let's say if we have a program that searches and it's using binary tree for traversing, deallocating, and allocating. In this table, which is from a paper called Ranking Programming Languages by Energy Efficiency, you can see the energy efficiency of C doing the task, and JavaScript, and then Python. Just to put that number in a perspective, if the same program that we saw earlier is running, let's say, 100 times during a day and during the entire year, this is the amount of energy that it comes out at the end, around 18.1 kilowatt hour, and for JavaScript, it's around 3.16. Now, to put it in more perspective, let's say this is the number of energy consumption around the world. For Germany, it's around 295 kilowatt hour a month. For India, it's 90 to 50 where you are. Rural Kenya is 5 kilowatt hour a month, not a lot. And in Colombia, it's 533. I don't know what they're cooking down there, but they use a lot of energy. And if we put Python, the same program that has been running a year, it can fuel a German home for around 2.5 days. And rural Kenya, it can actually run 3.5 months. And yeah, other countries 2.5, 6 days, Colombia 1 day. Same program, JavaScript, running a home in Germany, the same program that ran for a month, would run a home here for around 3 hours, rural Kenya for around a month, and Colombia for 2 hours, India between 3 hours to 1 day where you want. So these are, just to put it in a perspective of how a small program which has been running on your system for a year, if it's not optimized, if you're not using the correct programming language, how it can affect it. We can start also talking about how we can implement certain packages, programming practices to make Python more power efficient. I found some of the numbers online that were very interesting to me. And first one is this, the assignment operator versus the append operator. If you're looking at the first one, the assignment, not looks very pretty, but uses 4 times the less power compared to consumes less energy as compared to the append operator. But as programmers, we have to ask ourselves, which one would you prefer when you are doing your next code review? Which one is more pretty? I mean, that's the question that we have to ask ourselves too. Certainly for me, the second one is more readable. If I've never used Python in my life before, I would prefer the second one, but alas, it uses 4 times more power. Second thing, different ways to print a string. In Python, it says if you have around 10 million and you're 10 million inputs and you're trying to print it, it says if you're using the comma method, it's gonna cost you almost twice more energy to do it compared to all the other methods. Just to put it in perspective on how it might look like, and probably we should be using this comma method to print strings on large numbers. Talking about packages, we had two, NumPy and Panda, and I'm pretty sure a lot of people use this. And when taking around 10 million inputs and manipulating the data, you could see NumPy, it's faster and actually consumes less energy as compared to Pandas. Maybe it's because NumPy is mostly written in C, right? But if you have smaller amount of data, this research paper shows that Pandas is actually more efficient. Yeah, shocking. There is this thing which is called compiling for speed equals compiling for energy. There's also a paper which is called folklore confirmed compiling for speed equals compiling for energy, which means if you have a program and it runs full throttle and completes this task as quickly as possible, it is going to be more efficient. And I'm pretty sure you have all seen this formula somewhere in your life, energy equals power into time. So according to it, if time is less, you would be more energy efficient. There is one assumption in this formula though. Power needs to be constant. But according to this paper, which is really, if power is not constant, which is in case of our PC, in case of cloud computers, in case of all of these things, it is to some level true that less time you have, even if it consumes more power, it's going to be more energy efficient. And even if the power is not constant. Now, let's look at this table, which is very interesting, which shows the correlation between energy, time, and memory. And I have highlighted Python here because you could see Python has a very strong correlation to energy versus time, energy and memory and time. It means if we are able to save time or memory while executing our program, we are gonna definitely save some energy. And while you can also see some other programming languages which don't have much strong correlations in other terms, but Python really stands out, which makes it, at least in my perspective, making it efficient easier. While talking about all these solutions, and since I work for a cloud company, I think it makes sense for me to talk about microservices and cloud-based approach to all these problems. Let's say we have all these three problems in front of us, merge sort, quick sort, and removing duplicates. And someone tells me I have to implement it in the best and the most efficient way possible. I would probably pick the first three languages here, C, Pascal, and Rust. Unfortunately, I can't do all these three languages, but probably someone will and implement it. But as you can see, how less these programming languages are consuming the energy compared to their counterparts. And for me, a solution would be to implement all these in a cloud function and let them run instead of implementing all these three problems in one in one PC or in a one program. I have taken this program of remove duplicates and I have put it in a Lambda function. So there's this Python script which removes duplicates. And what it also does is it sorts it, so you can see the result. While running this program, you could see that it starts with 470 milliseconds, which is a cold start. It means it requires time to fire up the containers and everything. And even after that, there is not much of a change. It stays at around 450 to 460 milliseconds. Now we'll take a look at another program here, in Node.js and JavaScript. And you would see, firing it up, it takes 430 seconds, which is a cold start. But after it has loaded all the containers, it has done everything, the runtime is really down. It goes to 34, then 19, and then 14, which really shows that probably not putting all your programs in one language might be the best strategy. Now, comparing costs, let's say there are 10 million executions every month. We are putting 128 megabyte of memory. JavaScript, we assume 127 milliseconds, just every fifth invocation is a cold invocation, comes down to around $5 a month. Same program in Python, around $12 a month. So almost the double, which again proves my point that maybe it's time that we start using cloud computing more in order to optimize our programs. I'm going to leave you all with this question. Probably we can discuss more about it tonight. And thank you for listening. If you have any questions, please.
Thank you very much. One way to play the system is to ask exactly this question now. Who dares? Let's see. Any questions? Any questions? Okay, I have a question.
Please.
How did you measure this?
Which number are you talking about?
All of them.
Okay, so these are the ones that I have calculated myself using, you have AWS, you have a cheat sheet, which you can see how much it costs. The rest of the numbers comes from papers that I have marked here. If anyone wants links to them, I can send it to you. Yeah.
Okay, since I have this freedom, a sub-question, do these numbers change over time? Like in 1 year since now, will it change? And to how much? To which extent?
As I could tell, most of these papers did their research and the experiment on a personal computer. So I guess as hardware gets more efficient, of course, these numbers would change. But yeah, cannot say for sure. Yeah.
Good. Thank you very much.
Thank you.
Let's have our last talk now. Welcome, Dr. Alex. Great. You want to hear a lightning talk? No.
Huh? Thank you. Mein erster Meetup. Das ist nicht mein erster Meetup vor 100 Personen. Hey, ich schau vorbeikommen.
There's camera.
Okay, the microphone works.
Does it work? No? Yes? No?
Well, it's blue, and blue is not red. Blue usually means. Let's hope so.
Okay.
Wow, it's the right name. Wow, good. Nice name. Could imagine having this. Okay, then, we're not ready yet.
Almost there.
It was hot, but I think
gets better. Over ceiling
was
time
nicht
or
alkoholisch.
sunsets,
Meins. Danke, danke.
Yes.
Okay, so now Paul is going to tell us about TDD. Let's give him a warm welcome.
Thank you. Thank you, everyone. So my goal for today is just to give like an overview of what TDD is in my experience, share some ideas, and then maybe we can discuss further in the terrace. So my name is Pau Perez. I work for Tacto, this company, a local startup in Munich. I am backend engineer mostly from Barcelona, and currently I'm a tech lead at Tacto. So what is test-driven development? I'm going to assume a little bit of background because we don't have enough time. So basically, it's phrasing the development of your code in these three stages and going in cycles. So you start with a test that fails, you make it pass by implementing the necessary code, and then you move on to the refactoring cycle, and you keep going like this until you finish your task. So the whole point here is small iterative steps, right? So the first idea I want to share here is, in my experience, for this to really work, I think it's really important to approach this from top to bottom. So the point is you want the errors that your tests are going to throw at you to guide you from the abstract idea that you have, the thing that you want to implement, to something that works through these continuous feedback loops. How can this look like? So this is an example from our production code. I would personally start setting up a test. Let's say we're implementing a basic API endpoint, right? So I would first lay out the test. I know exactly which REST API I want to implement. I know the arguments I want to give, and I want this thing back, right? So that's the very first step, to get an error from the test, and then it's going to tell me there is no response here. And then I can move on and then make sure that the next error I get is something meaningful that guides me throughout the implementation. Another idea, and I think this one is really important. I'm not a super good developer myself. I acknowledge that. So I really want to minimize the time spent on unknown states. And what I mean by that is I really want to know what the error is about. And I don't want to have this feeling of being lost, when you see the error and you don't understand what's going on and you don't know what went wrong. So the key point here is you really need to take small iterative steps. And you may feel stupid, but really being on the known state all the time is what gives you this feeling of progress, and you are going to definitely be faster implementing things. Then another key idea I want to share here is that the whole point is to be on the consumer shoes. So basically, by having the test on your screen, you're going to be looking at how your code is going to be used by others. And I think that's really something I tick with me. Then from then on, I could really focus on the public interface of the code I was writing and how this can look like. So oh, you guys don't see it? Yeah. Okay. So in here, you can see how we're testing this mainly search slim adapter class. And the method that we're testing the public interface is right at the middle, right? So you're looking at from the outside perspective, and you're going to have the feeling what the consumers of that code are going to have. So you're really going to be forced to have a really nice public interface that others like. And I think that's pretty clear. The result is something that is clean, that is easy to understand, because if you don't understand it, you won't be able to write a test. As easy as that. That's another wrong slide. Then I think the fourth idea I want to really convey to you today is that the tests in the end are just here to increase confidence. And there's no approach, no TDD, no type of test that is going to give us the maximum confidence without any costs. And we need to be realistic here. So at the end of the day, it's about finding this trade-off between the costs of those tests, the risks that we're assuming without less tests, And also a very powerful idea, if you don't feel like a test is going to provide anything valuable to you, you can delete it. And then something that really took me a while to figure out, you might start implementing lots of tests while doing the TDD. But once you're done, if you see some tests that really don't add value, they're duplicate, they're going to be just costs. So it's fine to delete them and come up with something that has, a good balance between cost and risk. And that's pretty much it. So if you have any questions, guys. First question.
Microphone fellows. Yes, please. Hello, thanks for your talk. I wanted to ask two questions actually. The first is about can you sometimes when you develop test first, you can generate class from the test. I mean, some generates tools allow to do that.
Yeah.
Have you tried such or not? What's your experience with that?
So if I understood your question, you mean this type of unit testing? I think in Java they do that, where you have like a whole class where you have the setup methods.
Write test first, and then you generate code from test.
Yeah, exactly. Yeah, that's the whole point of this, right? So that's what I meant by the first idea, where I really approach it top to bottom. So I will really implement the most minimal test, like such an API test, that's going to tell me whether I'm getting there or not.
I mean, IDE can help you generate this result.
Absolutely, absolutely. And something to add here, and I think in favor of Python, is that I started doing this with Ruby, where there is no type system, or there wasn't any type system. Now, with the types in Python, this really is a lot easier, because it's going to be the IDE yelling at you what you did is not valid. Yeah.
And the second question is about when you develop some systems that are statistic, like you use LLMs, for example, like everyone uses AI now, and tests they will be also statistic. Like, what's your recommendation on that?
Yeah. Well, I'm not too much into LLMs, I have to say. I might be the opposite of many people here. But honestly, I use GitHub Copilot on my editor, and I think it's invaluable when you have your code side by side and you want to go to the next test, and it does it for you. I think that's really, really useful. I think TDD really benefits from that. I wouldn't say not to question that code, but it's really, you get an easier start when you want to start implementing your tests, definitely. I mean, you can get creative, yeah, but I haven't done that.
Good. Do we have more questions?
There.
Okay, I see one there.
Thank you for the talk. You mentioned that you're working on a startup, right?
Yes.
I was wondering what's your experience or your opinion with TDD in the startup environment? Don't you feel it could slow you down sometimes and so on? Because in the startup, sometimes you need to iterate very fast and throw away a lot of your code. So just wondering.
And then throw it in production.
I think that's a really good idea. A really good question, sorry. So to me, the testing is non-negotiable. I don't care who my employer is. That's out of the question. I think what you really learn is to find that sweet spot of the trade-off I mentioned, right? We cannot invest so much on, let's say, maybe a lot of end-to-end tests. Those are costly, take time to implement, lots of maintenance costs. Maybe the trade-off needs to be on the riskier side. At the end of the day, you're going to throw the code away, but it needs to be working while it's in production. So that's why, for me, just find the sweet spot, but don't stop doing it, because otherwise the code won't work. Yeah.
All right, big applause.
Thank you.
Thank you. Now the question is how we go from here. I don't really know. It's an experiment. But we have good news. The food has arrived. So I'm pretty sure this will be task number 1 for everybody. Then task number 2, because it is a networking spatial. We need to network. If you if you met less than 5 people, let's say, you cannot leave. This is like, we will put some guard on the door asking for new names you learned today for your new friends. Then finally, we got insights about interesting topics today from our speakers and lightning talks. Let it be kicking off the discussion. We have Johannes over there. Ask him everything about crypto, suggests collaboration, put questions, anything. Johannes will be hanging out here, so we will probably like split it by 2 terraces. I don't really know how, but really just go and talk to us. Then you saw whom to talk about hidden costs of Python development as well as TDD. I'm also in the TDD topic, so I'll probably join that one first. And like, if you have a nice idea to discuss, kick the discussion yourself. Like, we are open to any ideas, any discussions. It's our networking spatial, the first time, and I hope not the last time. Last but not least, before I shut up, we need a warm applause for Eugene, who is streaming, and Danny, who is organizing this. Hidden efforts of event organizing. Yeah. Great, thanks everybody. Now let's get this party started. The second part of it, networking. Thank you. Yeah. Jetzt? Super. Woo! More difficult than usually?